Hi everyone. Today we will look at the second part of graphical user interface in Python. Flip to, remember that we're going to use tkinter, and graphical user interface may be built on either canvas or frame. Of course, there can be also, canvas can include frame, while frame can contain canvas as well. But in this semester, we'll look at only separately canvas, how to use canvas and how to use frame. So we looked at how to use canvas, and today we'll look at how to use frame. Frame is more frame is a tool, is a container that can build the graphical components for most of the business the applications, while canvas is it can do also for business application, but more specifically for medical applications. But in general, frame is a good tool so that you can, for example, show the menus for user to choose, provide text field. We call here frame is a class. This is a class label that is also multiple of the classes that we are going to use. Label is to display some text. Entry is something that you want to take the user input, like a text field, so that user can type on it. Then you can use entry class. Button, that is very typical, so that if you click on button, then in response to the event of button clicks, you may want to further activate a function. Okay, so usually button is to identify the event and activate the actions in response to the events. So those are the class that we use. Now, they're all separate, could be independent classes. So next issue is that how we can lay out of those graphical components. Usually frame is on top container. Let's say this is a frame. So you need to create an object of a frame. Frame can contain inner frame as well. So this is another frame, maybe this is another frame, internally and another frame. Frame can contain inner frame, which can in turn contain the inner frame as well. A frame can have a label so that you need to display some, and it can have a text field so that you can make a text field for user to type on it. And then also you may create a button. So if a button is clicked, then some of the function needs to be activated. Then that function needs to be defined. So you have here a function to define. This kind of the function modules needs to be available. So the layout of the frame is a must, and only the functions that you define in addition to the layout of the frames, which it can contain labels, entries, buttons, string values. This is another thing that you say if you want to pass the arguments to a function, then you need to declare explicitly, hey, this is a string variable, so that string variable needs to be passed to a specific function. So this is something that you have to be aware. The way of the layouts in this class, as an example, we're going to use a grid. Grid is something that we can handle clearly and explicitly, rather than something else like place or 2 or 3 different ways that you can make a specific layouts. The grid layout is this. You can think in your mind. Let's say this is a grid. So a grid is a rows and columns. So let's say this is the first row. In the first row that you can place frame. In the second row of this frame, there's always a container and something contained in. So out the biggest frame here, that is the top level container. That container contains 3 inner frames. Then you need to lay out. First frame sits on the first row, and second frame on the second row, and next one is on the third row. If you make another frame also like this, maybe 2, 3 or more frames, all are contained in another upper level frame, then you need to do, hey, these frames are on the first row of this frame, but they are sitting on the different column. This is a column 0, which is the first column. This is the second column. This is on the third column. So row equals 0, column equals 0, row equals 0, column equals 1, things like that. So you can manipulate the place of the position of the graphical components within a container, which can sit on a specific grid within the upper level of a container. So more systematic way of layouts possible. So that's what we are going to do. This is an example that we are going to work. Not necessarily. This is something like here. This is a so-called. This is an entry. And this is a label, another entry, and another label. This is a button, okay? The one that we are going to work for our lab for today is exactly like this. Temperature converter. Temperature converter, this is a title, right? this, we initially make a top level or root level of a frame. That root level frame contains three, the inner frame. So we call that this is top frame, mid frame, and bottom frame. Top frame has only some of the labels, and mid frame, the label and entry. This is a text field. And bottom frame, this is bottom frame has also two inner frames, one on the left, one on the right. And on the left, we call that bottom left frame. On the right, the frame sits on the right is called the bottom right frame. The frame, for example, on the bottom left frame has a button and also a label, similar to the right ones. The scenario here is this. You type here any number. That is a temperature. If it is a Fahrenheit number, then by clicking this to convert to Celsius. For the same number, if you click this, then you assume this number is already in Celsius, so that you want to convert this number to Fahrenheit. So for the same number, two buttons, by clicking one either button, already assume that number is either Celsius or Fahrenheit, therefore convert it to in different measurement, so Celsius or Fahrenheit, and you display that number. Okay, this is what we want to practice. So steps that we need to do is basically we need to make a root frame and three outer frames on, actually this is inner frame, right? Inner into the top, the root level. So we have a root here, root frame, and it has a top, middle, bottom frame. Layout for that should be in the grid format, the row number 0, 1, and 2. Even further on the bottom frame, we have a left frame and right frame. Then column number 0 and column number 1. Therefore, one sits on the left, the other sits on the right. And to the value passing, in order to make a value passing, then we need to explicitly, so far we don't declare any variables, but for graphical user interface, we need to explicitly say, hey, this is a string variable, therefore string variable or string int, whichever that convenient for you, so it can be passed to. And label and grid, entry and grid, bottom and grid. And then finally, we have to do main loop. Remember that in the canvas, we practice that also. Main loop is required because event may occur after the first the display, right? Only this is a user interface. So when user enter into entry and click the button, then that is on event. Whenever an event takes place, then the graphical user interface needs to be re-rendered, re-displayed. So looping should be required. So we have to do main loop function. Main loop function needs to be in. So pure native Python code, then you need to have a plain loop. This statement is needed. At some points, if we use some editor, sometimes on Python also, or some code studio. Microsoft has also Microsoft or some of the studio, right? Some of the editor or IDE is provided. If you rely on IDE, as far as that IDE is powerful, then automatically inside it does main loop. So you may forget, or sometimes they don't want you to put main load because main load is on me. That's what they said, right? But real native code, you should have a main loop. Okay, see, yeah, that is what we are doing. And okay, practice now. So this is a Python. So we need to first import tkinter import everything, and we need to put here convert to Celsius, and I want to do simply type pass, which means I don't want to make any the error because that function is not defined. So I said here that function is defined. So one function is to convert to Celsius, the other one is convert to Fahrenheit. And I simply say pass, which means when it comes to the invocation of that function, pass, don't do, okay? And then we need to first create a TK object, and I want to call it root. You can call it anyone as you wish, but I think previously we called that top or root. But in this case, I want to call the inner top frame top, and middle frame is mid, and bottom frame is bottom, as I said. So I simply say root. Root is the top, the outer container. The root title, and I want to call, in this case we use frame, or simply temperature converter. Temperature converter, and then root dot geometry. I would simply say make it a little more the general purpose. Then we can say format, and then we can send whatever the number, or we can receive that number from when we create an object of this TK. That may be possible, but let's do like this. And then root, then main loop, right? At the end. And let's call this, let's say, GUI camp. I want to say here GUI 2, let's say GUI 3 frame dot py. Py is already here. Save, and let's see how it works. Okay, geometry. Oh, I need to put here x. So 300 times 500 times 300. Save. So that temperature converter, this is the container, and we want to put here something that we want. This is the previous ones. Okay. So as I said, on top we need to have 3 frames. I already made that here. So 3 frames. So top frame, that's contained in root. We define the root. Width of 500, as we did here, 500, and height 50. And the middle ones is height 150, and the bottom one 100. So all total then 300, which is the height of the container. Background, according to RGB, the top one is more red, bottom one is more blue, and in the middle like gray. Okay. If we have this, then we need to do layout. So that layout using the grid. So we have here top frame dot grid row 0. That sits on the top within that container. And the middle one is on the second row and third row. Sticky, I want to stick it to east-west, which means in the middle. North, south, east, west, which means center, because this is a little bigger ones, and this is in the middle of that. Okay, so let's see how it goes. So we have here the top one, like orange. This must be orange color. This is a gray, and this is like blue, right? So far, so good. And then the bottom one, then we need to have little further. So I would put here this is called the top frame, top container. Container. So bottom inner container is called the BTM frame. Within that BTM frame, so width is 500. So I want to divide it half. So 250, 250. one on the left, the other one on the right. Height, same height, but in different color. And also we have to do the layout with in gray. So left two ones on the same row, but in different column. Sticky, one on the west, the other one on east. What that means is that the left one push it to left, right one to be pushed to right. Okay, and let's see. Right now, we didn't change the color, right? Background color 1187FF, they are exactly the same, right? I don't want to make a different color here, but internally, I want to manipulate that. On the left, that is for example, convert to Celsius. Right ones is converted to Fahrenheit. Within my code, I need to divide them, but I didn't intend to distinct for user to use. Okay. And then I need to put label on top, right? So two labels created. So I call that guide equals label, which are on top frame. Text temperature converter, and then two lines on top, right? So how can we make a layout of two lines? Then the first label that is on the row 0, next one is row 1, and both are on in the middle of that row. So east-west and east-west. And I want to make similarly on label and entry on the middle frame. Okay. And I want to put all here together. So I have a label, enter temperature, and entry, I make an entry, and then label is on top of that frame, and on the second line, I put text field, which is entry, and then this initially I want to make it comments, and right, and see what happens. So I have here right now they pushed it up here, this grid, even if it is a center. So I want to put here some of relative x and y coordinates. Therefore, this should be placed by keeping the width and height. Therefore, we need to remove this, include this, okay, and then it will be like this. So relatively, it sits on the center of that, and XY here. This entry is on center. So from left to right, there's a 50%. From upper to here, that is 50%. On that is the center point. I want to place that entry, and little above, I want to put the label. That's what this guy is doing, these two lines. Okay. And then also we have a button and labels on the bottom, where there are left to we call that bottom left and bottom right. I'm going to simply put like that. Okay. And that is this. Boom. Okay. So upper one is bottom left, bottom one is bottom right. The code very similar. Okay. So we have a button and label, and two are in the layout in this like this, and then placed relatively as we looked at that, right? All very similar to the above ones. Only here bottom is the first one that we looked at. Bottom is on the container bottom left frame, BTLFM. BTLFM is already defined here, right? Bottom left. And we call the button, there is a button label text. I call that 2 Celsius. The other one is 2 Fahrenheit. Then we need to define, we need to call the function, right? Then that function can be in this command, okay? Command the parameter. So command equal, and this is a function definition from here, there. Like here, but lambda, this is called so-called the lambda function, okay? Lambda function is somehow temporary function. It's not really defined, the function like here, but that function, therefore, there is no function name, but function is anyway defined here. So this is a function call, convert to C or convert to F. These functions should be explicitly defined. That's what we did already. But here, look at this. These are the parameter, argument that we have to define within this function definition, temporary function definition. That temporary function definition start with the reserved word lambda, okay? Those who are measuring mathematics, then the lambda function is very, very famous function definitions. You may be able to see not only the math majors, but also computer science or cybersecurity majors needs to know this lambda function. This is, for example, if you have a job interviews, then they may first ask you what is a lambda function in Python. Then you have to clearly explain that the way that I just explained. So lambda function, so we don't need to define function name, but we need to define arguments. This is a frame name. If we want to send the frame name, then I name it f. This is internal variable f. That internal variable is passed the first argument here. And d equals text field input. Another t equals text field output. Out c. D and t also passed here. D and t, they are also arguments when this function is invoked. These are the variables. Excuse me. Let me take water. Okay, so t input or t out c. If you see here, t input t, those are the things that we need to take from user, right? Entry. These are the values that we want to pass to the function from graphical user interface. Remember that if we want to pass to graphical user interface, then we need to declare that explicitly somewhere like this. We need to do this. So T out, C, TF, T in, those three are defined. Okay, we call this variable declared for value passing. Okay. Actually, this may not be needed. Okay. So T out C, T out P, those two are defined, and T input, that's already defined here. Okay. So let's try to see. So buttons are declared here, and I want to put here 33. This is whatever the degree. It could be in Celsius, could be in Fahrenheit, depending upon the button that I am clicking here, right? So if I click this Celsius, then do something. But right now, because I didn't do anything. First of all, I sent here 3 arguments for each. But when I receive here, I didn't make that way, right? So that is the reason it has an error. So I want to make a function definition instead of this. 2 functions defined. So in, out, T input, T out, C, both 2 are, 3 parameters received. And first of all, the user input, when you pass this, then we cannot use this immediately because these are coming from the graphical user interface. It's not like general function calls. Okay, general function calls, we simply use this. But if it comes from the graphical user interface, then you need to get the value from this get function. Okay, because this is a true object orientation fashions. So we need to convert that to floats, and this is the formula that you can convert to Celsius from Fahrenheit. So given Fahrenheit F minus 32 times 5/9, then that will become as Celsius. Then you need to that Celsius C takes only 2 decimal points, like here, colon 0.2f, plus you need to put here C for Celsius, and then there's a degree sign. Degree sign is not really available in your keyboard, but we can emulate it in this Unicode. So in that Unicode, that's a \U, and 00B0, that is the Unicode, which is, remember the small circle, that is the degree symbol that's attached to the number in temperature, followed by C or F, right? That is once. And then we need to, whatever the outcome of this conversion needs to be written on the graphical points, right? On the label. Here is another label. That label that is contained in the left frame on the bottom. And what should we put? We need to put this this value needs to be set to send it back to graphical user interface. And if we want to see that value, then we need to do get function. So set function to make it in object orientation, and then to get the value, then we need to have get the value. So this is a label. This is within the function, right? Then you need to set it back, and when it comes to the receiver, then you need to make a get. That is just like from this one, originally from the graphical components. To get the value, then we use get. And whatever the computation, we need to return back to the graphical components, then you need to do set. So get is to read the value from graphical components. Set is to push it back to that objects. So get that, and we set the font, Helvetica, boldface, and background color, and the foreground color. This is the foreground color. And we need to write on that the labels. What it written there is number, and then temperature, followed by the character C or character F. This output should sit within this left frame, the first column, second row, whatever that, right? Not necessarily, second row. Why? Because on top there is a button, and then the one below, so there is row 0. This BTLFRM, this is BTLFRM, then this button should be on the row 0 and column 0. button on top, and then the next line, then there is a result of that temperature, right? So temperatures should be that. And this is a try and this is something that you do not see this. What happens here is that this is an exception handler, so-called. When there is an exceptions or errors, then so far your code terminates, right? If you do not want to terminate your code, but you want to manage it somehow, then it doesn't terminate, it's still to be alive, depending upon the way that you handle. But in this case, so in this try in the try block needs to be executed. If there is some error, some exception occurs, then depending upon exception type, then you need to do some of the handlings. But we don't implement that handlings here. We simply pass, okay, this level of codings. But later, for example, cybersecurity majors, we have another course. There's a secure coding. Then we handles that. For math majors, of course, don't do any additional codings, right? For computer science, not really any additional security sensitive codings or intelligent codings available. But anyway, that's what you can expect further. So this is a try except blocks that you first see here, right? If you don't do try and except blocks, you simply use this. This is everything that you need. If you trust user doesn't do any mistake into user graphical user interface, then you could do. But for graphical user interface, then we need to take care any unforeseen mistakes, errors, or attacks even needs to be taken care of, right? Therefore, we do try and accept. The other way of conversion to Fahrenheit, very similar to the above. Only difference here, this formula. Given Celsius, you need to multiply it by 9/5, and then finally add 32 to it. Others the same. With that, I need to. This is stopped, so I need to interrupt and restart and run this code. Okay. So, for example, I'm not sure today's temperature, maybe 57. 2 Celsius, which means I assume this is in Fahrenheit. Then it goes to, if this is a Fahrenheit, 57 degree in Fahrenheit, that is a 13.89 in Celsius. Let's assume this is a Celsius, and I want to convert it to Fahrenheit. Oh, that is over 100, right? So click this, 134. 60s. Okay, this is the code, and which you can enjoy. And the final homework assignments for this semester is do this exactly the way that I did. Okay, practice at your side, and you don't need to do any additional. simply do the way that I do. Okay. All right. Thank you. See you later. Bye.